Hello, good day everyone. So today we're going to discuss coordinates of a basis. Coordinates. For our objective, we're going to find the coordinate matrix relative to the basis in R raised to n. Coordinate representation in R raised to n. If B is a basis for a vector space V, then every vector x in V can be expressed in one and only one way, as a linear combination of vectors in B. The coefficients in the linear combination are the coordinates of x relative to B. So, the coefficients in the linear combination are the coordinates of x relative to B. So, if you have V1, V2 as your vectors, so if you have x to be written as a linear combination of V1 and V2, so that is C1 V1 plus C2 V2. So the coordinate would be C1 C2. So the coordinates would be the coordinates of x relative to B to the basis B is the coordinates or the coefficients of the vectors. So let B be equal to V1, V2 up to V sub n be an ordered basis for a vector space. So ordered basis, it should be at a specific order. So x is equal to C1 V1 plus C2 V2 plus Cn Vn. This set of coordinates C1, C2 up to Cn are the coordinates of x relative to the basis B. The coordinate matrix or the coordinate vector of x relative to B is the column matrix in R raised to n whose components are coordinates of x. So we just write it as a column vector. So the coordinates of x relative to B is the set of coordinates C1, C2 up to C sub n. Find the coordinate matrix of negative 2, 1, 3 in R cube relative to the standard basis. Relative to the standard basis, so you have negative 2 times 1, 0, 0 plus 1 times 0, 1, 0 plus 3 times 0, 0, 1. This would give us negative 2, 1, 3. Thus, the coordinate matrix is negative 2, 1, 3 coming from this one. So it is the same if we are referring to the basis, which is the standard basis. So if the natural basis or the standard basis is used, so the coordinate matrix is equal to the coefficient matrix. So the components of x are the same as its coordinates relative to the standard basis. So if x is equal to a, b, c, then ABC is equal to the coordinate of x using the natural basis. So the coordinate matrix of x in R squared relative to the non-standard ordered basis. So if this is the non-standard, so that is not the one that would give us 1, 0, and 0, 1 respectively, not the natural basis or not the standard basis. The basis vector is 1, 0, and 1, 2. If this is the coefficient matrix, we're looking for the coordinate matrix of x relative to the standard basis. So first, what we're going to do is to write 3, 2 as a linear combination with the coefficients 3, 2 for 1, 0 and 1, 2. This is your vector v1 and vector v2 on your non-standard basis. So 3 times 1 plus 2 times 1 is 5. 3 times 0 plus 2 times 2 is 4. So you have 5, 4. Now, using the standard basis, so the coefficients or the coordinates with respect or relative to the standard basis is 5, 4. So this to graph this, we can have the non-natural basis and when converted into the standard basis. So the standard basis is This is 1, 0, and this is 0, 1. So it is orthogonal, it is perpendicular to one another. But on this case, your first vector can be 1, 0, but the second vector is inclined. So the resulting vector is still looking the same. So that's all. Thank you for listening. Bye everyone.